the best way to wrap your head around recursion is just to write recursive methods. So we're just going to look at a lot of examples of recursive methods. We're going to start out with writing a couple of recursive void methods, and then we'll look at writing some recursive valued methods. So what I strongly encourage you to do is to pause the video and to write these three methods on your own, or one at a time, for example, and see if you can write the recursive solution on your own and test it out and make sure it works, and then come back and watch the video and I'll go through the solution as well. So the first example we're going to do is we're going to write a recursive method that prints each character of a string like on its own line. So for example, if you invoke the method with the word dog, it'll print D on one line, O on the next line, and G on the next line. Then we're going to write a recursive method to double all of the elements in an array. So you pass an array into a method that contains 1, 2, 3, for example, and after the method ends, the array should contain 2, 4, 6. And then finally, we'll do the same thing, only we'll double the elements in a list rather than the elements in an array. Okay, so we're going to write those three methods. These are all examples of void methods, meaning they don't have a return value. Again, I encourage you to pause the video and write the solution on your own to start with. One thing to keep in mind is that remember that a lot of times when writing recursive methods, we often need additional parameters outside of what we would normally need to accomplish the task. And so when that happens, it's best to create a helper method. And that helper method will take in those additional parameters, and that will be the method that's actually recursive. Whereas the original method that you would call from a client, for example, won't be recursive. It'll just invoke the recursive helper method. All right, so let's start off with writing a recursive method to print each character of the string. So what do we need for our parameters? Well, we've already said this is a void method. It's not returning anything. It's just printing things out. So what kind of inputs do we need to take in? We need the string. I'll just call it a string word that we're going to print backwards. I'm sorry, to print the characters. Print characters. Okay, so we're writing a recursive method, so we want to think about our two cases. We want to think about the base case and we want to think about the recursive case. So thinking about this as, again, a really hard problem that we don't know how to solve, but we could solve a little bit now and solve the rest later and then know when to stop, we'd have a solution. So the idea is, okay, I don't know how to print each character on its own line, but I know how to print the first character on a line, right? I can just say system.out.println word.substring01, or you could also say word.char at 0. Either of those would print just the first character. And then we can say, well, I don't know how to print the rest of it, but if I knew how to print the first character, and if somebody else could print all the rest of the characters, then I'd be done. So the idea is we then want to recursively call this method with what? Well, we want to call it basically with word minus the first character. So how can we do that? Well, the one way we could do that is we could use the substring method. So there's two different substring methods. Recall that the two parameter substring that I just used here finds the substring starting at the first position, so in this case position 1, going up to but not including the character at the second position, start at index 0, go up to but not including the second index, index 1. So this would give me the substring starting at index 0, and that's it. Another way that you can check to make sure you're using the right parameters here is that the length of your substring is this minus this. So in our case, the length of our substring is 1 minus 0, which is what we want. We want the first character. So this prints the first character. And then what we want to do here is we want to repeat the task with the rest of the word minus the first character. So how can we do that? Well, again, we can use that substring method. So we could say word.substring. The second substring method only takes one parameter, and that method gives you the substring of the word starting at this index and just going to the end, right? So this just basically cuts off the first character of a string. So we could do that, right? So this would be our recursive case where we're saying, okay, we'll solve a small part now, and we'll solve the rest later. What's missing? We're missing a base case, right? If we were to invoke this with, print characters, hello, it'll have infinite recursion, right? And actually, instead of infinite recursion, at this point, it will throw an exception because it'll eventually get to an empty string, try to take a substring, and you can't do that, so it'll crash. Okay, so we don't have a base case. We don't have a way to tell the recursion to end. So let's create that base case. What should our base case be? How do we know we're done? Probably two logical base cases. One would be when you reach a string of length 1, or when you reach a string of length 0, and then you're just done, right? So either one of those would be good base cases. Let's say we will choose the one where we stop at 1. So we could say if word.length is 1, then what do? We print that character, and then we're done, right? No recursive call. So this is our base case. And our recursive case is in our else. And in our recursive case, we still need to print the character, right? So we want to print the character both in our base case and in our recursive case. But the difference is in our recursive case, we print the first character and then we also go forward and invoke the method again. Okay, so this should work. Let's give it a test. HELLO exclamation point. So it does. Now, you might notice that we have some repeated code here. You actually notice that I copied and pasted a line of code, which I tell you is never a good idea. Whenever you're copying and pasting code, there's usually a better way to go about it, and that's true in this case as well. So how can we rearrange this method so that we don't have this line of code repeated? Well, I'm going to leave this code here, comment it out so that we have it there for reference. But what could we do? Well, we can notice that this printing happens in both the base case and the recursive case. So we say, if it's going to happen no matter what, if it's going to happen in the if and it's going to happen in the else, well, maybe I just pull it outside the conditional, right? So, okay, this happens no matter what. So let's start with our same code that we had before. If this statement here happens both in the if and in the else, then it doesn't need to be in the conditional. It can just come outside the conditional. So let's just pull it out before the conditional. And we say, okay, pull it out from here. So there we go. So now when we get into this method, we say, okay, we'll print the first character no matter how long the string is. And then if the word length is 1, we're done. And otherwise, we recursively call the method. Okay. Now, it's not really a great idea to usually leave empty conditionals like this. Those kind of don't logically make a lot of sense. So what we can do instead is we can just transition this to say, instead of checking if the length is 1, we can check if the length is greater than 1. And only in that case, this is now our recursive case. Okay. So essentially we have now an implicit base case. But that's okay because there is at least a conditional that says, okay, if the length is greater than 1, go ahead and make that recursive call. But once the length is equal to 1, we're done and the recursive call won't happen. So both of these implementations will have the same outcome, right? So if we run this, we'll see the same effect, okay, same output. But this one's, I'd say, a little bit better because it doesn't repeat that code. Okay, I think it also is kind of a little bit more logically how we think about it, right? We say, okay, print the first character, and then if there's more to be printed, go ahead and do the job again. So I actually think that in this case, this streamlined version is also more logically consistent with how we think about the problem. Now, what would happen if I moved this print line to after the recursive case? So before you run it, think about that for a moment. What would happen? What's going to print out? All right, let's go ahead and find out. So it still prints all the characters, but it prints them in reverse order. So why is that happening? Well, let's think about that. When we invoke this method with the word hello, what happens is we check to see, okay, is the length greater than 1? It is. So we put the hello version of this method on pause, and we invoke print characters with the ELLO exclamation point version. Then we come into the method again. Is the length greater than 1? It is. So we put that ELLO method on pause, invoke it with the LLO exclamation point. Come in here. Is that length greater than 1? It is. So we put that version on pause. We invoke with the LO exclamation point. Is that length greater than 1? It is. So we come in here, put that method on pause, come in, invoke with the O exclamation point. Is that length greater than 1? It is. So we put that method on pause, come in here with just the exclamation point. When we come in with the word that's just the exclamation point, we say, is that length greater than 1? No, it's not. Our if condition fails. So we just move on to the code after the if, which is the print. So we print that exclamation point. Then that version of the method is done. It gets taken off the runtime stack, and we go back to the method that was paused and pick up where we left off. So we pick up in this line on the O exclamation point version of this method. Now the if is done, so we just print out the O, which is the first character. Then that method is done, comes off the stack, control returns to the LO exclamation point version. So we pick up where we left off, which is here. We're done with the if, we print out the L, and so on. So there's this winding up and this winding down that we always have with recursive functions, and you just have to pay really close attention to what's happening before the recursive call and what's happening after the recursive call. Okay, so in this case, the before, originally we had the print line before, and that will allow us to print the characters out in order. When we switch it and put the print line after, that will then print in reverse. Okay, what would happen if we had them in both places? What would print? Again, think about it for a minute. So then let's run it. So it's going to first print out the word in forward order, and then it's going to print it in reverse order, right? Because it'll basically print the H, then put that on pause, recursively call with the smaller string. Get in there, print the E, recursively call with the smaller string. Print the L, recursively call with a smaller string, and so on down to print the exclamation point. Then at that point, this if fails, so we print another exclamation point. You can see the two exclamation points next to each other. And then that method's done. So we return control back up again. It picks up here, prints the L, and then that method is done. We return control back to the previous method, print the other L, or the if is done, we print the other L, then that one's done, and so on. So this very simple example is actually a really good way to think about how recursion works and what it means to have code before a recursive call and after a recursive call. And it's also a good reminder that, a common mistake I see is that when a recursive call is done, people just finish the method. But it's really important that you have to go back, and if there's code after that recursive call, it's still going to be executed. So you can't kind of forget about that code that happens there. Now, one other change I want to make to this print characters method is recall that strings are immutable. Right, so strings, their value cannot be changed. So when we invoke word.substring, we're not actually shrinking the current word. We're creating a whole new word based on that substring. So this is pretty inefficient because every time we invoke this method, we're creating a whole new string. Now, with a string like hello, that's not a big deal. But if we had a string that was some crazy long, million character string, we would not want to be creating a new string a million times. Right? So we can write a method that instead is a little more efficient. So I'm going to call it print characters efficient. And the parameters are going to be the same because from a client's perspective, from the perspective of someone invoking this method, they still should only have to send in a string. If we decide we need more internal parameters to make the method work, then we can create those in a helper method. But someone invoking our method should still only have to send the parameters required for the task, in our case, the string. So how can we make this more efficient? How can we write this method so that we don't have to create a new string each pass through? Well, if we had an index, we could print out characters that in that index and then just track until we're at the end of the string. And that way we could just use the same string over and over and over again. So what we need is an extra parameter to help us track where we are. So I can write a private helper method that takes in the word, but then also takes in an index. Okay. So now what we're going to do is our small part of the problem we're solving now is to print the word at that index. So instead of at 0, we're just going to print it at the index. And then we're going to say, okay, well now instead of checking whether the length is greater than 1, we can check if what? So for this method, I'm just going to print forward, okay? So we print the first character. We're going to assume that, that'll be the character of position 0. And then we want to say if what? What are we checking? What is our recursive case going to be? Well, if that index is what? If that index is less than word.length, we want to make the recursive call. And we recursively call our helper method. And what do we pass in? We pass in the same word, but what do we pass in for index? We pass in index plus 1. So we move the index forward 1 space. So this is our recursive call. Now, are there any, I've got my base case, right? So I have my kind of explicit base case here. I've got my recursive case. How do I invoke this method? What do I pass in for my initial index? So I want to invoke my print characters efficient helper, and I'm going to send in the word, and then what is my index? My initial index is just 0, right? So I'm going to print the character at 0 and then say, well, if 0 is less than, in our case, this length is 6. So if 0 is less than 6, I make a recursive call. Now, is this going to run correctly? So we're going to print 0. 0 is less than 6. We'll make the recursive call with the same word and index 1. We'll print the character at index 1. Then index 2, 3, 4. Now, how about when index is 5? We will print the character at index 5, which is the exclamation point. Is 5 less than 6? It is. So we will then go in here, make the recursive call with 6, but is 6 a valid character? No, index 6 is out of bounds. So if we run this, we're going to actually get an exception. Because we have tried to access a string index out of bounds. So what can we change this to instead? We can change it to whether the index is less than word length minus 1. All right, because the last one we want to print is that word length minus 1. So once that is the value, we want to stop the recursion. So now when we run this, now we'll see that we get that printout again. Okay. And what's nice about this is that we have not created any new strings, so it's much more efficient. Again, with a small string like this, it doesn't matter. With a much larger string, it would matter. So you always want to make sure you're not creating new objects when you don't need to. Okay. And things that instances where that happens a lot is when people are working with strings or people are working with arrays. Sometimes it can be easier to think about just taking a substring or making a copy of an array, but that's not very efficient. So even though some people think this maybe doesn't look as clean of a solution because you've introduced this other private method, it's much more efficient. And it's better to have an efficient solution rather than a, smaller lines of code solution. Efficiency always is going to trump out over that. Okay. So the other thing to make sure you're very careful about is off by 1 errors. So just like in loops, off by 1 errors are very easy to make. Same with recursion. Getting off by 1 errors are very easy to make. And with recursion, they can lead to either infinite recursion, or in this case, it led to, the program crashing with an exception. So you want to be really careful about those border cases of your base case or of your recursive case. Okay, so there is our first task of printing out the characters in an array. So next up, we're going to print a recursive method to double the elements in an array. So what parameters do we need to take into this method? We need to just take in the array, right? So let's take in the array. And we want to double all the elements. So let's say we had some array. 1, 2, 3, 4, 5, 6. We want to be able to call double the array, and it'll double all those values. So let's print them out before and after so we can see. Remember that how we print out the contents of an array is with the static arrays.toString method. So we'll print it before and after. And of course, I now need to import the arrays class. Okay. All right. So what can we do here? Well, we want to take this array and we want to double all the elements in it. So, okay, that's a hard problem. What's the small part I can solve now? And what's the part I can solve later? Well, the small part I could solve now is I could say, I don't know how to double everything in the array, but I know how to double the very first element in the array. I can say the array at position 0 gets whatever that array at position 0 is times 2. That would double the very first element in the array. And then how do I solve the rest of the problem later? Well, I could recursively say, okay, now we want to call that double array with the rest of the array minus, not the first position of 0, because that one's already done. So this would kind of be the small part now, and this would be the larger part later. But how do I do that? How do I send in only part of an array? Well, there isn't a great way to do that. Okay, so what I think I might need to do is I might need to make a helper method, and that helper method is going to help me track where I am in my array. So let's write a private helper method, and we'll again take in the array, but then we'll also take in an index. Okay, so now I can say, okay, whatever index I'm looking at, I can take that index and I can double it. And then I can just solve the problem again, starting at the next position, which will be index plus 1. Now, how would I invoke this method? What's my first index going to be? It's going to be 0, right? That's the first position that I want to double. Okay. Now, what's going to happen here as it's written? Am I going to get infinite recursion? Well, it's a bad solution. It's not going to stop, but instead of having infinite recursion, it's going to again throw an exception because I'm eventually going to go out of bounds on my array. So similar to how we did it in the string case, we want to make a conditional, and we want to say, well, as long as that index is what? Want to say as long as the index is less than array.length, we can go ahead and double it and invoke it, invoke the recursive call. So this is going to be our recursive call. This is going to be the small part we're solving now. And this is the recursive call. Now we again have an implicit base case, so it's not explicitly stated, but because our recursive case is inside a conditional, we're not going to have that infinite recursion or array out of bounds crashing. Now we could have written this as the same structure as we did up here, where we kind of had moved the doubling code outside, and then we would put the recursive call, check that it's less than array.length minus 1. But I just want to show you another way to write it. So in this case here, I put everything inside the conditional, and we're basically just going to do the small part inside the conditional and then have the recursive call. Both solutions would be correct. It's just kind of a different way to write it. Okay, so let's go ahead and test this. So we've got 1, 2, 3, 4, 5, 6, and then we have the array doubled. Now, one thing that's important to remember about how this is working is how objects are passed as parameters and that arrays are considered objects. So when we pass our array into the double array method, arrays are objects, so what we're actually passing is the value of that variable. We're passing the memory address, so it's just one array being passed into this method. That same array reference is passed into the helper method and passed along in between each recursive method call. So we come in here with a memory location of array and 0. In our case, our length is 6. So we say, okay, 0 is less than 6. We double the value at position 0, and it's only one array that we're working with. Then we recursively send in that same memory location of the array as well as index 1. 1 is less than 6, so we double that position, the value at that position, and then we recursively invoke the method with that value of the array, which is the memory location, and the index 2, and so on and so forth. So it's going to be similar to that picture where we had all of the arrows pointing at one student object. It's going to be the same thing with an array. In our case, we're going to have 6 recursive method calls, and they're all going to have an arrow to one single array because arrays are objects. So when we pass an array into a method, we're passing the value of that array variable, and that value is a memory location. It's a reference. So all of our recursive method calls are sharing that same one array. They just all have different references, different variable names pointing to the same place in memory. So changes made to that array inside each recursive method affect the array everywhere because there's only one array. Okay, so that's an important thing to keep in mind. Okay, last up for our void methods here, we are going to do the same thing we just did, only we're going to double the elements in a list rather than in an array. So we're going to have a similar setup here, but we'll take in a list object, and we want to do the same thing. Okay, now, do we need a helper method here? would say, yes, we do, right? Because we need some way to track how we're moving through the list. So we'll create a private helper method. It again takes in that list object and an index. And what we can do is something very simple. We can basically say, okay, the value at position index, so get that value, and then we're going to double it. We're just going to say list.set that index to that value times 2. Okay? And then we want to have our recursive call with the same list and index plus 1. Now this again is, we don't have a base case here, right? We only have a recursive case. We have no base case. So we need to add one, and we can add kind of the same thing. We can say as long as index is less than list.size, go ahead and do all this code. So this is our recursive case. And we have our implicit base case. What do we initially invoke this helper method with? 0, right? Because that's our first index. So if we create a list to test this, and then we'll print it out and double our list, print it out again, we can see that the method works. We'll get 1, 2, 3, and then 2, 4, 6. Okay, so same idea as with the array. And again, we have an object. So there is one list, the value of one list is being passed around. That value is a memory location. So every time we set the element of that list with a different recursive method call, it's the same list being modified because it's only one object. Now, one last note that I wanted to make here is let's see what would happen if we use index plus plus instead of index plus 1. Look what happened here. We got a Stack Overflow error. Stack Overflow error is infinite recursion. Essentially what Stack Overflow error means is that you are putting so many methods on that runtime stack that eventually this runtime stack runs out of room and you get a Stack Overflow error. That's the exception you'll get when you have infinite recursion. Okay. Now the reason for this is because of how the postfix increment operator works. So index plus plus, it actually increments the value after it returns the value. So essentially we are passing index the same number every single time, right? So we're passing 0, 0, 0, 0, 0. So we're having infinite recursion because we call double list helper with index 0. We do this code and then we call it again with index 0 and we call it again with index 0 and we call it, where essentially it's the same as if we'd done this. Because what happens is we call with index 0 and then after the call is made, after that value is evaluated as a parameter, then it gets incremented to 1, but it doesn't get passed as 1. If we were to use the prefix notation, it'll work. So I tend to avoid that because I think it's troublesome, problematic, and it's too easy to make a mistake. So I always recommend you just use index plus 1 instead of using the prefix version of the increment operator. You're welcome to use prefix or you're welcome to use this index plus 1, but be very careful about using postfix because as you've just seen, it won't work correctly. And that's a very easy mistake to make. And it's also kind of an a hard mistake to track down because the logic of your program is totally correct. It's just this funky thing about how the postfix is evaluated, that's where the trouble comes in. In general, I always advise to not use the increment or decrement operators inside things like method calls, recursive or otherwise. I always recommend keeping them for when they're in statements by themselves or as part of a loop, for example, the loop controls, but I always recommend avoiding them in method calls or in assignment statements because it just is too easy to make a mistake. So just one more thing to be aware of. So there you go. There are some more examples of recursive void methods.